crystal systems and Bravais Lattice. This is Dr. R. Jalababu, lecturer in chemistry, SCIM, Government Degree College, Tanuku. The learning objectives of this video, first one is space lattice, unit cell and parameters of unit cell, types of unit cell. Next one, crystal systems, lattice points, and finally Bravais lattice. First one is space lattice. Space lattice means in a crystal how particles are arranged in regular three-dimensional fashion. An array of points represented in space, it is the space lattice. Space lattice may be one-dimensional, two-dimensional, or three-dimensional based on the number of parameters required to define the space lattice. So the first one is one-dimensional lattice. In one-dimensional lattice, the particles are arranged in one-dimensional and the distance between these particles is represented by A. So the repeated distance A. So the one parameter is required to define the one-dimensional lattice. Second one is two-dimensional lattice. In two-dimensional lattice, so in the crystal, the particles are represented in two-dimensional. So the distance between these particles is A and the another direction. So the particles distance is the B and the one interfacial angle gamma. So for the two-dimensional lattice, the two distances between the particles and one angle between these planes, that is the gamma. For two-dimensional lattice, two distances and one angle is required to define two-dimensional lattice. So the next one is three-dimensional lattice. In three-dimensional lattice, so the space lattice is representing in these three directions. So that is the distance between these directions, that is the A and B and C, three repeating units, and the angle between the planes, that is the alpha, beta, gamma. So in three-dimensional lattice, three repeated units and the angles alpha, beta, gamma. So this is the three-dimensional representation of the space lattice. So the briefly types of lattice: one-dimensional, repeat distance one distance, the interfacial angle, no interfacial angle for one-dimensional representation, and the number of parameters required defining the lattice one, repeat distance. For two-dimensional lattice, so repeat distances A, B, interfacial angle gamma. Two repeat distances and an interfacial angle is required for two-dimensional lattice. For three-dimensional lattice, repeat distances A, B, C, interfacial angle alpha, beta, gamma. So in three-dimensional representation of the space lattice, three repeat distances and three interfacial angles are the required. So next one is unit cell. Unit cell is the smallest repetitive unit which gives the total crystal structure is called unit cell. The unit cells are repeated over in 3 dimensions and result into the whole of the space lattice of the crystal. So unit cell is the smallest repetitive unit. So the number of the unit cells are repeated in 3 dimensionally and finally give this the total structure of the crystal. What are the parameters of the unit cell? So unit cell in 3 dimensional representation, that is along the x-axis, y-axis, z-axis. Along the x-axis, so intercept A and the distance between this center to this intercept A. Along the y-axis, from center to this intercept B, the distance is the B, and along the z-axis, from center to intercept C, that the distance is the C. Along the xyz axis, x, y, z axis, so the distance at the intercept of A and on y axis B, on z axis C. And the angles, the interfacial angles between the xyz axis, that is the alpha, beta and gamma. So the interfacial angles are the alpha, beta and gamma. So for representation of the any unit cells, the parameters required, that is the A, B, C and alpha, beta, gamma. Next one is types of unit cells. So unit cells are the 4 types mainly. There are the 4 types. So the first one is primitive unit cell. It is represented by P. In primitive unit cell, it is the cube. It contains the 8 atoms or ions at the 8 corners of the unit cell. And second one is body centered unit cell. It is represented by I. In this body centered unit cell, 8 corners representing 8 corners, they are the 8 atoms or ions are present, and at the center of this cube or center of the unit cell, one, that is the atom or ion is the present. Next, third one is face centered unit cell. It is represented by F. In face centered unit cell, 8 atoms at the 8 corners, and each face it contains the one atom. This cubic system contains 6 faces, so they are the 6 atoms are the present at the center of the face. So this is the face centered unit cell. So the fourth one is end centered unit cell. It is represented by C. In this end centered unit cell, 8 atoms are at the 8 corners, and this end and this face and this end face contains the 2 atoms. So this is the end centered unit cell. These are the 4 types of the unit cells: primitive unit cell, body centered unit cell, face centered unit cell, end centered unit cell. Next one is types of crystal systems. So the four types of the unit cells forms, there are the seven types of crystal systems. Seven types of the crystal systems by the four types of the unit cells. The first one is cubic system. In cubic system, the intercepts A equals to B equals to C, and the interfacial angles, that is the alpha, beta and gamma equals to 90 degrees. Both are the same, that are the equals to 90 degrees. Okay, this is the cubic system. Here the distance A, B and C all are in equal distance, and alpha, beta, gamma are also equal and equals to 90 degrees. Okay. So the examples for the cubic system, NaCl and diamond. Next, second one is tetragonal system. The tetragonal system, A equals to B but not equals to C, and angles alpha, beta, gamma equals to 90 degrees. So this is the tetragonal system. A equals to B. Here A equals to B. This distance and this is the same, but this is the different. Is not equals to C. Here alpha, beta, gamma all are the equal and equals to 90 degrees. Okay, this is the tetragonal system. Example for tetragonal system, SnO2 and TiO2. Next, third one is orthorhombic system. In orthorhombic system, A not equals to B and not equals to C. Here A, B, C all are the different, and but alpha, beta and gamma equals to 90 degrees. So this is the orthorhombic system. So here A is different from B and B is different from C, but the all angles are equal and equal to 90 degrees. So the example for orthorhombic system is matchbox. So here matchbox, so this distance, this is the length and the width and height. So here the three distances are the different, but these angles all are the 90 degrees. So the good example for the orthorhombic system is matchbox. Okay, and the examples for the orthorhombic system, KNO3, MgSO4, 7H2O. Next, fourth system is monoclinic system. In monoclinic system also, A not equals to B and not equals to C. And the angles alpha equals to gamma equals to 90 degrees, but beta not equals to 90. So here the A, B and C different, and alpha, gamma, these are the 90. Beta is not equals to 90 degrees. Okay. So the example for monoclinic system, Na2SO4 10H2O, FeSO4 7H2O. Next one is triclinic system. For triclinic system, A not equals to B and B is not equals to C. Angles alpha, beta, gamma not equals to each other and also not equals to 90 degrees. So this is the triclinic system. A and B and C are different, and alpha, beta, gamma also different and not equals to 90 degrees. And examples for triclinic system: CuSO4, 5H2O, K2Cr2O7. Next, sixth one is rhombohedral system. For rhombohedral system, A equals to B and B equals to C. And angles alpha and beta and gamma are equal, but they are not equals to 90 degrees. So this is the rhombohedral system. So the A, B, C are equal and alpha, beta, gamma also equal. But these angles are not equals to 90 degrees. If the angles also equal to 90 degrees, that is the cubic system. But then for rhombohedral system, alpha, beta, gamma not equals to 90 degrees. So here example arsenic, antimony and bismuth. So the seventh one is hexagonal system. For hexagonal system, A equals to B and not equals to C. Here A and B are equal, but C is the different. And angles alpha, beta equals to 90 degrees, but gamma is 120 degrees. So for hexagonal system, so this is the A and B. So these two distances are the same and the C is the different, and alpha, beta 90, but gamma here 120 degrees. Example graphite and ice. So the total 7 type of the crystal systems. So one is the cubic, intercepts A equals to B equals to C, angles alpha, beta, gamma equals to 90 degrees. Example NaCl and diamond. Next, second one, tetragonal, A and B are equal and not equals to C, alpha, beta, gamma are equals to 90 degrees. Example SnO2 and TiO2. Next one, orthogonal system. A and B and C are not equal and alpha, beta, gamma 90 degrees. Example KNO3, MgSO4, 7H2O. Next one, monoclinic system. A and B and C are not equals to each other and alpha, beta equals to 90, but gamma is not equals to 90. Example Na2SO4, 10H2O, FeSO4, 7H2O. For triclinic system, A not equals to B and not equals to C, alpha not equals to beta, beta not equals to gamma and not equals to 90 degrees. Example CuSO4, 5H2O, K2Cr2O7. Next one is rhombohedral. A equals to B equals to C, alpha, beta, gamma are equal but not equals to 90 degrees is greater than 120 degrees. Example arsenic, antimony, bismuth. Hexagonal system, A equals to B and not equals to C, alpha, beta 90 degrees, gamma equals to 120 degrees. Example graphite and ice. These are the 7 types of the crystal systems and their intercepts and angles and examples. So if you take the cubic system, so this is the center of the cube and it is the corner of cube, and this is the face, and this is the edge. So there is the only one center for cubic system, and face, there are the 6 faces, 1 2 3 4 5 6, and corners, the faces are 6, only center is the 1, and corners are the 8. They are the 8 corners, and edges, there are the 12 edges. The 4 and 4, 8, and these 4, total 12 edges. So this is for the cubic system, one center and 6 faces and 8 corners and the 12 edges. So the next one is lattice points. So the lattice points representing atoms, molecules or ions in a unit cell. So in unit cells, the atoms or molecules or ions are represented by the points. So these points representation is known as the lattice points. So the 4 unit cells, the first one is the primitive unit cell. So this primitive unit cell, it is the 8 points. There are the 8 points at the 8 corners of the unit cell. Okay. So it is the corner. This corner in the crystal, it is the shared by these. They are the 1 2 3 4 5 6 7 8. So the 8 unit cells. This corner point in crystal, it is associated or the shared with the 8 unit cells in the crystal. So the corner point, it is the, how many corners here? There are the 8 corners. Each corner point representing with this 8 unit cells. So the each corner is contribution 1 by 8. So the corner point in the unit cell, it is the shared with the 8 unit cells in the crystal. 8 unit cells in the crystal. So that is the contribution is 1 by 8. So the primitive unit cell contains the 8 corners. So the 8 into 1 by 8. So that equals to 1. So the primitive unit cell, the total number of the atoms for unit cell, that is the 1. So the number of points per primitive unit cell equals to 1, because there are the 8 corners. Each corner is the contributed with the 8 unit cells. So next, lattice points for face-centered unit cell. So the face-centered unit cell, it contains the 8 corners, 8 points, and also each face contains the 1 point. So 6 faces, that is the 6 points. So the point present in the face center, so this face is shared with the 2 unit cells. So for 1 unit cell, that is the 1 by 2. So how many faces? 6 faces. 6 into 1 by 2, that is the 3 atoms or ions. And along with the 6 faces, they are the 8 corners. So the corners contribution 1 by 8, and they are the 8 corners, that equals to 1. So the total number of the atoms for face centered unit cell, 1 plus 3, that is the 4. Okay. So the total equivalent points for face centered unit cell equals to 1 plus 3, that equals to 4. So the next one is body centered unit cell. For body centered unit cell, it is the 8 corners, 8 atoms, and also at the center of the unit cell, 1 atom. So if the center, it is the contribute to the only one unit cell. So this center point, it is belongs to the only one unit cell. So the total number of the atoms for the body centered, the 8 corners, 8 into 1 by 8, that equals to 1, and center point, it contains the 1 atom, so that equals to 1. Total 1 plus 1. There are the 2 equivalent points for the body centered unit cell. So the total equivalent points for the body centered unit cell, 1 plus 1, 2. So the fourth type of the unit cell, end centered unit cell. The end centered unit cell, it contains the 8 corners, 8 into 1 by 8, that equals to 1. So here only face centered at the two ends. So this is the one end and this is the another end. So there are the two atoms with the face center. So the face center contribution is 1 by 2. So that is equals to 1. Okay, here also 1. So that is the 1 plus 1, that is the 2. For total equivalent points for end centered unit cell, 1 plus 1, that equals to 2. Okay, so the next one is Bravais lattice. So the Bravais scientist showed that is the lattice points can be arranged in the 14 ways in the space. These 14 arrangements are known as Bravais lattice. So the total 4 types of unit cells and 7 types of the crystal systems, which are the shown in the 14 ways in the space. These 14 arrangements are known as Bravais lattice. So the Bravais lattice are the 14 types of the arrangements in the space by the 4 types of unit cells and 7 types of crystals. So the first one is cubic system. So for the cubic system, A equals to B equals to C. Okay, and angles alpha, beta, gamma equals to 90 degrees. So these cubic system, these unit cells are arranged. This is the primitive, body centered and face centered. These cubic system parameters A equals to B equals to C and alpha, beta, gamma equals to 90. For these parameters, these cubic systems are arranged in the 3 types of the unit cells, that is the primitive unit cell, body centered unit cell and face centered unit cell. For this cubic system, there are the 3 types of the Bravais lattice. So next, second one is tetragonal system. For tetragonal system, A equals to B and not equals to C. Alpha, beta, gamma are equal to 90 degrees. For tetragonal system, 2 types of the unit cells are the possible, is the primitive and the second one is the body centered. For tetragonal system, 2 types of the Bravais lattice are possible, primitive and body centered. So the third one is orthorhombic system. For orthorhombic system, A and B and C are not equals to each other and alpha, beta, gamma 90 degrees. Okay. For orthorhombic system, 4 types of the unit cells are possible, primitive, body centered, face centered and end-centered. So for orthorhombic system, four types of the Bravais lattice arrangements. And next crystal system is monoclinic system. For monoclinic system, A not equals to B not equals to C, and alpha gamma equals to 90 degrees and beta not equals to 90. For monoclinic system, so the primitive unit cell and the end centered, these two Bravais lattice are the possible for monoclinic system. So the next fifth one is triclinic system. So the triclinic system, A not equals to B not equals to C, and alpha, beta, gamma are not equal to each other and not equals to 90 degrees. So for triclinic system, only primitive unit cell is possible. So triclinic system 1 Bravais lattice. So the sixth one is rhombohedral system. For rhombohedral system, A equals to B equals to C and alpha, beta, gamma are equal but not equals to 90. For rhombohedral system, only primitive unit cell is possible. So that is the only one Bravais lattice. And finally, for hexagonal system, A equals to B but not equals to C, and alpha, beta equals to 90 and gamma equals to 120 degrees. So for hexagonal system, only primitive unit cell is possible. So that is the one Bravais lattice for hexagonal system. So the Bravais lattice are shown here in briefly. So for cubic system, these are the parameters. That is the Bravais lattice are the 3. For tetragonal system, 2 Bravais lattice are possible, and orthogonal 4 Bravais lattice, monoclinic 2, triclinic 1, rhombohedral 1, hexagonal 1. So totally the 14 Bravais lattice for 7 crystal systems. Okay, thank you very much.